Greetings everyone. My name is Adam Hems. I'm one of the leaders of the Houston Azure User Group. A warm welcome to everyone here in person. I see some folks, a bunch of folks joined us online. We'll probably get some more. A warm welcome. We've been running this together for years now, trying to do this every month. Who here is new? First timers? Some new, actually, a lot of them. You not been here before video? Yes, your first time. Okay, I know some of you, but all right. Well, warm welcome to the newbies. Greetings. So what we're about is an opportunity. So, Kim and I, our day jobs are cloud all day. That's what we're doing. I've been doing it for over a decade now. It's a decade of full-time cloud. It's just all we focus on all day in our professional lives. This is an opportunity to do that as more of a community where folks can learn from one another and the speakers as well. Not something we really get a chance to do so much in our professional lives because it's different, right? That's our day jobs. This is more about fun, learning from each other and sharing experiences because the technology is the same, but the business problems differ. So who we got in terms of oil and gas folks here today? Okay, often see it's Houston. Often see some oil and gas. Healthcare, that's the other one. No, healthcare today. Consulting, we get quite a few consultants. Few hands. Yeah, consultants. Always consultants. Yeah. Consultants. It's a good place to learn, right? And talk and interact. I do consulting today. So. Education. We got some education folks. Yeah, education. Retired. Ray, yes, yeah. So retired folks come here to learn. Yeah. He's only 95. Can you believe it? He doesn't look a day over 98. We tease Ray because he's a regular and we like him, so that's why we tease him, because we like him. All right, so our food tonight is sponsored by Microsoft. So thank you, Microsoft, who also allow us to use this room, so we appreciate that. And without further ado, let me hand over to our speaker tonight, a returning speaker by popular demand, Vin, who actually has been 18 months since spoken before. I can't believe it's actually been that long, but I have a lot of texts, a lot of questions about today, so it's, I think, very well anticipated. His last one was really good, so we're expecting this one to be even better. No. All right, without further ado, Vin, please take it. You can just start presenting and take over.
Hey guys, excited to be here. Has anyone used Claude Code?
Yeah. Use what?
Claude Code.
Claude? Claude, yes.
Not the LLM, Claude Code.
The product.
Yes. Yeah, so if you haven't used it, please use it and and tell me what you think. Like all the inspiration for this talk originated from Claude Code and GitHub Copilot. My name is Vin Kamath. I work for H&R Block. Been working there for almost 21 years now, and this is what I do. I eat, drink, sleep AI. I'm very passionate about it. I love Azure AI Foundry and Azure OpenAI services, Cosmos DB, all that good stuff. And the AI architecture is my full-time job. So let's get started.
I think I have someone online.
Okay. All right. So AI agents, right? So if we had to pick one word to describe this past year, it's probably AI agents. Agent is all people talk about these days, and it's like I'm not, carried away by the hype because what I see day to day is exciting stuff. What you can build, problems you can solve in your businesses, and if you do that, then you don't have to get carried away with the hype. Let me see what's going on with my something strange.
What you see on the screen is
Okay. So if you don't use HR block, please use it to file your taxes. It's my job to say so, and I love saying it because I'm proud of it. I've worked on some of these products. We have online tax filing, online and tax flow, so you can hand it off to tax flow, or you go to one of our 10,000 offices, file for in person. We also have free second look to review your return and offer you better refund. So last year and the year before that, we talked about RAG, basic RAG, right? Retrieval augmented generation. So what happens here is you take the user query, think of it as a, like a simple Q&A chatbot. You turn it into embeddings, which are numerical floating point representation of the query. You query the content index, and then you send it to LLM, all the context you get. This is basic RAG. So this was exciting last year, not anymore. So we're well past that, very old, but I wanted to kind of ground you in where we started. And I can share the slides if you go dive deep into it, but I'll focus on agents. So there's lots of definitions of AI agents, but this one is my favorite. It makes total sense to me. An AI agent executes tools and skills. Skills is a new pattern that Claude kind of published recently. And the bounded term is very important here in a bounded loop. So the loop is important, the bounded loop is also important to achieve a goal. And this goal can be provided by the user who's interacting with the application, but it can also be from the system. In cases of automation, a system can ask for tasks to be performed. So this is my favorite definition. And Simon Willison, go read his blog. I read it every day. He publishes some really insightful essays. So this definition is derived from his definition of an AI agent. The next question is, when do you need an AI agent? Because you don't need an AI agent all the time. It depends. So if you have fixed rules, you can do rule-based automation like we have been doing all the time, although you can white code it. So branched predictable paths can be addressed using rule-based workflows. The only time you really need an agent is it's open-ended, non-deterministic. We don't know what the query looks like or the task looks like. And there is tool choices, right? Not one tool, but many tools. And there is a critic reasoning loop that's involved. That's when you need an agent. So if you look at any problem statements that the business brings up or the product brings up, you have to put on this lens of figuring out, do you really need an agent? Of course, there's products like Copilot Studio that you can use to build agents. But the question is, do you really need it? Is there something better? So the litmus test that I kind of feel like is really important is if you can pre-draw the path of the execution, don't ship an agent. If it is non-deterministic, you don't know what to expect and you don't want to code for every possible scenario, that's when you build an agent. I'll pause for questions. Spoken for 5-10 minutes here. Any questions?
What if it's deterministic?
Sorry?
What if it's what if you know the outcome or the cases?
The question is, what if you know the cases, or what if you don't know the cases?
Yes. So the definition here, if you can pre-draw the path, don't ship it as an agent.
Yeah.
What should I ship it as?
Your regular old applications,
Regular.
non-AI?
Yeah.
Yeah, like we did all these years.
Or a
Same
Power
thing.
App if you're a non-technical user.
Yeah, because you know the path, right? You know what the execution looks like. There's absolutely no need to use AI and complex, make it complex.
Excuse me. You said Foundry view.
Mm-hmm.
It's very important.
Yes.
elaborate on that?
Yeah, I'll get to that.
Okay.
Yes.
Are you seeing, you said there's a lot of hype, are you seeing a lot of people trying to create agents when they don't need to?
Exactly. That's why this slide exists, because everyone wants to build agents. They feel like you can solve any problem, but not really. The other thing about it is evals. So if you cannot measure what the agents produce in terms of outputs, then you don't really need an agent either, right? So one of the first things we do is come up with a golden data set. What does the input look like? Get it labeled by the subject matter experts, and then run it through your agents and see what the output looks like. Does it map to the labeled golden data set? What does the accuracy look like, right? So there are about a dozen metrics, and if you go to Microsoft Learn and look for evaluations, you will see that there is very detailed guidance about those metrics, and this is an important phase of the project. You end up spending probably like 60-70% of your time doing evals. The build out is very easy. That's why you go to any hackathons and these innovation sprints and so forth. Like people ship these prototypes and they demo them, right? So demoing it is easy, but to go to production, you got to have evals, and you have to do a lot of work, especially with product, to figure out what does that golden data set looks like. Do you have a team of subject matter experts who can label that data? So a lot of operational work has to be done. I'm assuming most of you know Azure AI Foundry, so I'll save this for the end of the session if you guys really need to go down that path. I was hoping I could.
You want to roll forward when you get to this content?
Yeah, exactly.
Okay, I was going to ask you what AI Foundry is, because I'm not sure I know. But if you feel like
You don't?
have time,
Okay.
it's fine. If you don't have enough time, it's fine. We can use it at the end. So I've completely forgotten what it is.
It's one of the hot services in Azure. That's why Adam is saying that. But here is where you can go in and deploy models, right? So this is like any other Azure resource. You create a resource, there's a project, and there used to be hubs. A lot of confusion about projects and hubs, but all it is a resource where you can deploy the models. So this is a serverless model. You don't have to worry about compute. You just have to specify what kind of model you like. So you can type in and select a model. There's a model catalog, GPT-5, 5 mini, Codex, whole bunch of models. So when you say confirm, this is the most important dialog box. So here you have to choose the deployment type. If you have legal and compliance, requirements, then you can use data zone standard, which is what we choose because it adheres to the US data residency laws. But there are a whole bunch of others. For prototyping and experimentation, probably you can use global standard. And then for production, I highly recommend something like data zone provision throughput. This gives you dedicated capacity, so you can buy like a minimum of 15 PTUs, and you have to load test it and make sure your volume is covered in those 15 PTUs. If not, you have to keep buying them. It's like renting an apartment. You rent for a given PTUs, and then it's you don't have to worry about like tokens and that kind of stuff. You have to obviously measure it, but your usage entirely depends on PTUs. There is a whole bunch of literature about PTU optimization. So once you go to production and you start using PTU-based models, that becomes a own field of study. Okay, so then there is like all the customization you can do, content safety, which is awesome, by the way. Content safety is really important. Not gonna go deep, but this is Agentic RAG. So think of this like V2. A lot of boxes, but I'll quickly go through it. From application use AI, a query is sent, but this time you don't turn it into embeddings. You directly send it to LLM, okay? And the LLM says, I need to make tool calls. And one of the tool call would go out and fetch the relevant content for that query, right? So here, one of the key differences is the query is created by the LLM. It's not what the user sent. So those two things can be different, right? So we trust the LLM to create those queries. And we run them through the content index. So if you follow through the steps, 1, 2, 3, and then once the context is retrieved, you assemble the final prompt and you send it to LLM. And this happens in a loop, okay? So remember I was talking about bounded loop, right? You want to make sure this is bounded. You don't want this to go indefinitely. So one of the patterns I'll speak to is the budgeting of the tool calls. So you want to set budgets based on your use case, and that way you can control how many tool calls it can make before it can produce a response.
And the difference between this and the RAG previously is the two small green boxes after the entry point
And the loop.
in the loop. Yeah.
Yeah. Now that this is simplistic, you can make it much more advanced and complex, but this is the most simple agentic RAG. This is also known as LLM search because LLM is the driver for the search. Okay, time for the demo. So I didn't know what kind of demo would make sense. I wanted it to be simple, and this is what I came up with. I'm calling it the file search agent. So I have a bunch of files in my folder. Imagine this is your my documents or something, and you wanna run this query. What was that file I did last week where I said something about something, right? Like it could be like budgeting or whatever. So I jump to the demo. Okay, so I can't type and do this at the same time, so bear with me. So let's say typing So what's happening now is this query is sent to the LLM directly. It's also offered a bunch of tools, and in this case, it decided to use the Glob tool. So the Glob tool is simple code, C# code, exposed to the LLM as a function. It tries to find files matching a pattern. So in this case, it came up with this pattern. It sent this request to the function, and the function is like regular code, looks up, and then returns this response saying, I found a file. And once it goes back to the LLM is able to respond to it. And then there is a modified date, size is this, so on and so forth. Now you can say, ask some follow-up questions. You guys can hear me, right?
Yeah.
I know I speak very low, but
With that mic, we can hear you fine.
okay. So this time it ran the grep tool multiple times, right? So this is what is unique about this. You don't have, there is no predetermined path. So if I say hello, what do you think should happen? No tool calls, right? Now imagine last year, this is not what happened. We took the hello, we turned it into embeddings, and we searched in something like Azure AI search, vector databases, and you got the response, you sent it to LLM, not required. And that's the power of agents, right? And the beauty is you can do this for any problem, any domain. And if you design it well, you can literally automate anything you want. That's why I'm so excited about it. Now I'll grab some more queries.
So when you say hello, when
Yes.
you said hello, it did not execute any code, right?
Correct.
And where did it get the prompt that says, what, how can I help you?
That's LLM doing its thing.
That's the foundation model.
Foundation.
Yeah.
Exactly.
Currently, is there any MCP behind it?
Sorry?
Is there any MCP behind the LLM?
No, absolutely nothing. And that's why these patterns are something I learned from Claude Code and GitHub Copilot. So originally, a lot of complex architecture took over for some of these coding agents. But the reason Claude Code is so successful, in my opinion, is because it's simple. The architecture is simple, the solution design is simple. There's lots of YouTube videos where the creators of Claude Code talk about how they built it and why it works. That was my inspiration of chasing the tail on how coding agents work. So some of the problems you can solve in our businesses, right, whatever domain you are in, can come from coding agents. Because if you look at any agent on the planet, like if you ask yourself, okay, what's the most successful agent, AI agent? It's got to be one of these coding agents, right? Cursor, Lovable, V0.
I'm just being your prompter here.
Mm-hmm.
Somebody who is remote is asking, can you please explain how hello did not need a cool call, how it decided? I'm just reading.
Yeah. So the question is, how hello didn't need a tool call is because you are. It's kind of hard to explain, but follow along. Okay. What you do is you write a comprehensive system prompt. In that system prompt, you list out all your tools. Okay, and you explain what the tools do. What are the input parameters? What are the output parameters? All of that stuff. And I'll get to some of the first principles in the end, but one of them is providing high quality tools. If your tools suck, then you probably are not doing your job. So if your tools are very high quality, right, like everything is absolutely clear, no ambiguity, right? Because the only time LLMs make mistakes, we have found the hard way, is when you cannot tell what the tools do and they're ambiguous. There's no clarity. So in this case, because we are first reaching out to LLM before we run through any execution pipeline, the LLM knows if I just have to greet the user back. I don't need to make a tool call. I know what tools are available to me. So this is the reasoning. So all the reasoning models do this really well. Of course, GPT-4.1 also is really good at it. But the 5 series model really do it well, like very reliably, because they have been trained to do this.
So, in that example, how many agents you have?
One agent. So that's another thing I'll get to, is always start with just one agent. This whole hype about multi-agent, we have learned the hard way, it doesn't work. You can get to multi-agent only when you have proven using data and evals that the single agent doesn't work, right? That's when you decide, let me add a sub-agent. Until then, there's absolutely no need to do it.
I mean, there are use cases it needs multi-agent, multi-different.
Correct. A lot depends on the context window at any given point. How much of the context is filled with what's required for this task versus that task. So depending on that, you have to decide, is a single agent enough or a multi-agent is required. 80% of the cases, maybe not.
My understanding was that if you have a lot of different tools, then it would be good to split that apart, because sometimes the LLM can get confused on which tool it should
Exactly.
use.
I think depending on the problem you are solving, right?
Yeah. So for example, GitHub Copilot, if you install a bunch of VS Code extensions, like I've got like 148 tools. So every time I open it up, I deselect all the tools so that it can be faster. Because now it has to decide which tool am I going to pick out of this long list, right? So let's run this.
One last question.
Yeah.
Is it Azure Foundry? I haven't used it.
Mhm.
Is it similar to Bedrock in AWS?
Yes, something similar. Way better. No, I'm kidding. Use whatever you like.
But let's say you have a situation where you do something periodically, maybe once a week or once a month or whatever. So you set up an agent in order to follow the same steps that you do. And all you have to do then is look at what comes out and make sure it makes sense. But you can, and if you have a series of those things, you can have one agent that calls these other agents on, because it knows the times, and then you have a multi-agent system.
That's true.
You can have a judge and also for the email.
You can have a separate LLM, yeah. Recently, one of the things we learned is a use case for fine-tuning, and that could be evals. We are yet to prove it. We are doing experiments with it, but fine-tuning LLMs was never a thing, at least for me. But recently, we have learned that you can fine-tune LLMs and use it for evals, not for actual runtime, but you can use it for evals. So here it goes in and calls the grep tool, and if you look at the situation here, it first called the glob tool, did the pattern matching, and then did a grep tool. It came back with this response. So I can go on and on, like any query I can send. I have about like a dozen files in that folder. There is no vectorization, no embedding, simple code that allows you to execute these tools, and then you tell the LLM what to do with it. And at work, we have applied some of these patterns, and we have found that the accuracy, the quality of the response goes up tremendously when you apply some of these patterns. Now the downside, because there's always a downside and trade-off, is the latency it takes for you to come back with a response, right? So you have to do something called as progress reporting. So you have to handle it through UX and really make sure your backend is optimized for performance. So there's a lot of work that goes in the backend.
In your world at work, I would imagine there's a lot of, maybe not deterministic, but expected subject matter, and
Yes.
so can caching help you improve performance, save tokens, etc.?
It can, but one of the challenges with caching is the assumption that two similar looking queries are actually similar. What we have found is they may not be. They look similar, especially in our domain, tax domain. A law in California and a law in New York may look similar, but they are different. So now you run the risk of responding with a cached response that may not be accurate. So in domains where accuracy is number one priority, caching is something you want to avoid, and we have avoided it. Now, I'm sure there are areas where it's applicable. I don't like it personally because it throws up a whole bunch of other curveballs where you have to come up with a test suite to catch those edge cases, and that effort is even more than what you would have saved if you didn't do caching.
Yeah.
So
the question is purely out of ignorance.
Mhm.
In a domain like taxes, why are you doing LLMs/agents and not rule-based deterministic systems, which is what you want to do, right, as an accountant and a
Yes.
tax expert? So
yeah. So the question is, in a domain like taxes, rule-based engines are really the way to go. Why are we using AI and LLMs? It's a very good question, and we don't use AI for any of the deterministic situations or rule-based situations. Like our tax engine is built it's literally domain-specific metadata that's generating code, millions of lines of code. None of that has anything to do with AI, right? So the tax software is not where AI can be applied, at least not now. I don't know about future. But where we use AI is areas where you can't read all the path, like you don't know what to expect. For example, answering tax questions. So we have a product called AI Tax Assist in our online product, where you can literally answer questions from our proprietary knowledge base to answer your tax questions, like what is a child tax credit, or explain this law to me, or whatever that may be, right? Ask about tax forms. So that doesn't really require, like, we're not calculating your return at that point. We're giving you information, right?
You're doing similarity search, right?
Vector, hybrid search.
Hybrid search.
Vector and semantic search. So Azure AI Search provides that
Yes.
capability, and probably one of the really good mature product. One strength of Azure AI Search is high scalability.
Yes.
So you want to use that.
And have you guys, not to give away any secret sauce, but have you implemented any graph rag for domain expertise?
We did experiment with it, and at this point, like in November of 2025, the Agentic RAG works better than graph rag. The only time graph rag is something you want to look at is when you really have that knowledge graph. Like you first have to ask yourself, do I have a knowledge graph? Can I build it? Where do I host it?
Where it's
It
pre-existing.
involves a lot of operational complexity and deployment complexity. So although when we first heard of it, it was like, wow, this is awesome. But when you actually do it, maybe not. So this is the execution flow diagram. The key pieces or components here is, you see this budget. So right now I have a budget set for 10 tool calls in my app settings, and you list out these tools. You see my arrow there? Okay, thank you. So these are the 3 tools. Now imagine I can probably offer 10 more tools to make it smarter, right? Like I can add things that are much more intelligent than just some of these. I saw the glob and grep, and that's what Claude Code does. So I tried to learn how they do it and try to do it on my own. And then when the tool responds, it responds a JSON response from the tool. And then the LLM in this box decides, do I need more context? Sometimes I've seen it making multiple calls to understand what's going on across multiple files. And then if there is no more context required, then it generates the final response. Any questions here?
So when it generates the final response, does it evaluate the agent or the human?
There's nothing in this prototype, but in real world, what you want to do is you want to take that final response and create a data set and have it labeled by human experts. That's what you want to do.
You have pictures,
Mhm.
file, with the LLM also explain what the picture is.
Absolutely. Yeah, multimodal, all the frontier models let you upload images and stuff like that. So, yeah. So one of the mindset shift from last year to this year has been this: ask not what LLM can do for you, but what you can do for LLM. No, seriously, because when we started the journey, it was always about, oh, LLM can't do this or that, right? Like it cannot call tools reliably is one of the complaints. There are so many other complaints you can come up with. It hallucinates. It calls tools that don't exist. You can imagine all the challenges there. But the reality is, with the current class of models, what you really have to ask yourself is, what do you have to actually do to make the LLM give you what you want, right? Full credit
Said another way, those complaints are generally user errors.
Exactly, user errors, right? But there is a design process to solve those user errors, which is not simple.
And it may be iterative to get to
Very
your
iterative.
outcome.
Exactly. So I highly recommend watching this YouTube video by Eric. He works for Anthropic, and credits to him because he came up with this concept and it just clicked in my head like this makes total sense. Up until then, I was like, I cannot explain what I think about it, but I wanted those words. And he's talking about Claude, so replace LLM with Claude, and that's what he was talking about. But in reality, it applies to anything. You can say Copilot, right? If Copilot doesn't seem to do what you want it to do, ask yourself, what is the context it's missing? And how can you provide that context? Now we come to the busy slide. There are about 13 patterns. Please bear with me on this because I just want to share everything that I've learned. Don't have a lot of time to go through each one of them. But I do plan to publish more material about this, blog post or whatever, LinkedIn. But these are the patterns, and I've highlighted some of them. The bold ones are the ones that are really important, and some of the demos that you see here make use of these patterns. The most important one is the React pattern. So everything we talked about, the bounded loop, the tool calling, all of that is happening because we ask the LLM to reason and act. That's why it's called React pattern. This is not a new concept. We have tried to do this in RAG applications in the past, but this applies to everything, right? Because your tools could be making API calls, they may be setting up appointments, they may be approving a case, anything. So they take action, right? So it's beyond RAG. Number 2 is my favorite because it lets you set reasoning effort. So all the reasoning models have a knob to turn, a configuration that you can say minimal, low, medium, high. So based on the reasoning effort, the model thinks more or less. Okay, so if you set minimal, the reasoning tokens it uses to think about the problem and give you a response is lower, but it's fast, right? Like you get the response immediately. But if you set it to high, it takes a very long time, maybe 30 seconds in some cases, and it uses a lot of reasoning tokens, and you pay for those reasoning tokens. So when you set reasoning effort to high, you have to be careful to think about cost as well. Number 3, you already saw the tool call budget. This is what the third pattern is. So you want to think about your use case. Okay, in my case, I think I'm going to allow 10 tool calls and 3 searches. So you can add other kinds of budgeting here, not just tool calls. You may say, I want to set search budget to make that call to content index. Parallel tool execution. This is very prevalent in Agentic RAG, where the LLM may come up with 3 queries at once because the question could be multifaceted, right? For example, in taxes, the question may be about a specific type of credit in a specific type of state for a specific type of taxpayer, right? I'm married filing jointly or single or head of household, whatever. So there are multifaceted scenarios. You have to club all of them together, right? And if you run that query only once, that may not give you all the content that you want. So LLM may decide to break it down and run 3 queries, and you get all of them at once in your tools, and then you run them parallelly. So what you're doing is you're optimizing the performance. External prompt templating is nothing new. This has been there for last couple of years. So what you really do is, if you set a budget, for example, you want to replace the configuration variable in your system prompt at runtime so that the numbers can vary like the configurations. So you want to execute it and not hard code it. That's what that means. Structured output is for JSON. So if you have JSON responses, you can use them. Progress reporting, you saw how I was outputting request response. So because this is a technical audience, I'm showing these JSON snippets, but in real world, you don't want to do that. You want to explain in natural language. This is called show the work. So if you're working really hard to help the user, and you're taking a series of steps which are completely dynamic, You want to be able to explain to the user what's happening, and ChatGPT does it really well. So if you expand it, these are called reasoning summaries. If you click on it, you'll see all the reasoning, like I called this website, I got this content, and this is what I found, like, you know. Number 13 is what I'll demo it in the next demo, but this is about sandbox code sessions. So this is about generating artifacts. So when you have a use case where you have to generate artifacts, you wanna run this code interpreter, for example, in a sandbox. So this code could be static, but the execution is dynamic based on what the LLM tells you. The last one is agent skills. I'm still learning this pattern, and I have high hopes that this pattern will solve a lot of business problems. I can't tell you right now because I don't know yet. We started working on making some prototypes and experimenting with them, but I feel like this is a really good pattern. I have linked it, so that link takes you to Anthropic's website where they talk about skills. So this one is a little more involved and complex. Before I start that, any follow-up questions? Anything here? Yes, that is right. Answer to Chandra. Tool description is very, very important. We take in C#, you take the function and you annotate it with every possible explanation that you can give to the model. So yeah, it's very important. Yes, Scott, I'll share the deck. Code, I'm not sure. I have still work to do to get it to a point where it's easily consumable, but definitely I'll share the deck. So, in this demo, we're going to take a tax scenario. Married filing jointly filer. They've got two jobs, taxpayer and spouse, and get a bank interest. And what we really want to do using this agent is we want to generate tax forms. And you might ask, why do we need to generate tax forms? Well, this is a case of test data generation. So any domain, we want to have enough test data in the most real-world manner you can have, like, you know, representing the real world. And in order to do that, you have to spend a lot of manual effort, right? Now imagine a scenario where, you know, what happens in real world is our clients upload their tax forms, right? Like W-2s and 1099s and, you know, Schedule A's and whatnot. So when they upload them, what we have to do is extract data out of it to prepare the return, right? That's like the first step. And it's very hard to, it's not hard if you're an expert in taxes, you can probably sit down and produce these test data forms of what the real world might look like for our clients. But it's laborious and very intensive process. So one of the things that I was asking myself is, can we solve this problem? Can I explain a tax scenario, have the LLM make reasonable choices within the, you know, boundaries, and generate those tax forms, like literally PDFs, right? And if we can run this in batch, like imagine how much of test data we can generate. Of course, you're going to need tokens, but it's well worth it because, you know, manually people don't have to sit and spend all that time. Okay, so this is a simple filer, one full-time job and working as a junior civil engineer. Now you might think like, why did I say that? Well, I want the LLM to make some reasonable guesses of what the W-2 wage might look like, instead of me giving it, right? So this is where, you know, test data generation becomes really cool using AI agents, is because I can give it, you know, a choice. rather than me having to make the choice. And then verify if the choices that were made were right. So first thing you see here is that I ran the classification algorithm that decided, because this is a simple case, the reasoning effort is minimal, okay? And the first tool that I've defined is called parse stack scenario. In this case, it came up with this response saying, these are all the supported forms that I have in my prototype. Forms requested, okay, 1040 W2. The next thing it does, it calls generate synthetic data, okay? And look at what it came up with. It said, oh, junior civil engineer, maybe 67K, right? I didn't have to think about it, but when I look at it, maybe it's okay, right? Now, obviously, nothing against civil engineers, they may be earning a 3-digit salary. Good for them, but I'm just saying, like, you can imagine a scenario and have it make reasonable choices. So in this case, it sent this request, it came back with this response JSON. Now this JSON is validated for consistency. So remember earlier I was talking about only ship AI agents if you can measure it. So I've tried to embed a tool that validates the consistency. For example, I don't want a fictitious scenario where the wages is like 10 million, right? That's like, doesn't make sense. So there are many amounts here. If you go deeper into taxes, you'll realize there are many amounts, different kinds of values in this payload, which have to be consistent to each other to mimic the real world. If they are not, then you're not really testing it, right? So that's why this validate consistency tool call is important. And then the LLM says, okay, all data is consistent and valid. Now the next step is get form coordinates. So it looks up the PDF field coordinates for the W2 and then comes back with all these coordinates and what the description of the field is, and then it lays out the right values at the right coordinate. I didn't have to write all this code, is the beauty of this, right? I had to define what I want and only write code, the functions, right? The tools, all of these tools, where a deterministic action has to take place. That's it. So in this case, it went in and said, okay, success, and it created a W2. Here is a quick summary. I'll bring up the W2 just to show you. And all of this happened very quickly, in a matter of seconds. And there you go. So this is the form that I can use to then run through our other backend systems to extract, to check for data extraction. Now this has got real values, right? Realistic looking values, and we can change them, right? We can say, oh, you had a 401k contribution, so box 12A starts to fill up, and we don't have to write a very deterministic flow to do this. This is a good use case, right? There are a bunch of other forms that I'll show you using the same approach. So here is a 1099 int. Very different form with different values. All I have to do is, get some templates, bunch of templates. So I'll open up my VS Code now and show you some code. So inside here, I have decided, okay, I'm gonna have these 7 different forms that I'm gonna support, right? These are literally templates, blank templates. And then I have coordinates that say what field should go where, right? All of this is deterministic stuff. I don't need AI to generate these things, right? I can define them and offer this tool that does the work. What I want the AI to do is to generate synthetic data, and map that data to where the coordinates should go. That's all I have to do. So in this case, it gives us much more reliability. When I first started this, I was like, maybe I should have the LLM generate PDF. But think about how much of testing I have to do because it's so non-deterministic. But in this case, the testing is very limited because all I have to make sure is the data looks right.
So you
Now,
build these coordinates yourself, or AI did this part?
I had to iterate on it. The first time I used AI to generate the, of course I will use AI to generate the coordinates, right? However, it took a number of iterations to get it because once you get it, you can test it very easily. You can take the coordinates, put it on the PDF and see if it maps to the right location. So if there are some, like I'll show you one example where it didn't, like schedule A, okay? I did not iterate on this coordinates, and that's why you see the values printed all over the place, right? So that's why the solution design phase of how you lay out all these components is very important, and you want to make sure each artifact that you offer LLM has been tested. So, but you only do it once. You don't have to do it for every use case, every tax scenario in this case, right?
So just to make sure, when you say coordinates, you're talking about X and Y axis.
Yeah.
And what's the measure for those? In other words, when you say X is 100 and Y is 200, what does it mean?
It simply means if you take X and Y,
Yeah.
the starting point of where the value should be printed. In this case, the payer's name is printed at 710 pixel down and 173. Yeah.
Pixel is the measure.
Yeah.
Okay.
Now, I haven't really looked at it as pixel or rem or something else, but I don't really care. But in real world, in production, I would review everything.
No, I'm just trying to understand how did you measure
Mhm.
this thing? Are you trusting what the computer is telling you, or you're verifying, say, yeah, it's not 173, it really is 169 or something? How do you figure that?
Yeah, the question is, how do you verify if these X and Y coordinates are accurate?
Yes.
Here is an example where it's inaccurate, right?
Yeah.
Where it's printing all over the place. So what we really have to do is iterate on all the coordinates, but you do it only once during build time, where you develop these templates. And once you do, and we already have it because these forms is what we work on. I didn't use our company's X and Y coordinates. In this case, I had AI generated. But once you have it, then that's it. This is like a blueprint, right?
So in an earlier step, you were saying that you had all these tools that you fed it.
Mhm.
And so did you come up with essentially the processing, like the structure, and you're like, okay, build me the tool for this part, but you architected it and you had to
Yes.
fill in the blanks.
Exactly.
Okay.
So first I had to sit down and write a spec of what this might look like. And you should have a fairly good idea of what that spec looks like, how the components are designed. For example, I'll show you in the slide here.
And if you don't, something like BMAD code or spec kit can help you brainstorm
Yes.
through and it'll iterate to create that.
Yeah. So first thing I did is draw this diagram on a whiteboard. Now granted, this was generated by Mermaid, right? But first, I had to know, okay, where does the React loop start? Okay, I have to first classify the reasoning effort once the query comes in into minimal, low, medium, high. Hand it off to the agent, and the React loop starts, right? Then I have to set a budget, okay? Here are the tools. I have to first parse it, then I have to generate the synthetic data, then I have to validate the consistency, and then finally get the coordinates. And there is a form filler tool where, well, I need to show you the form filler tool.
I have a question.
Yes.
So you showed the classification box. before the agent.
Yes.
But isn't the agent making the determination whether it is simple or what's the reasoning model? Because it's natural language question, right?
Great question. So one of the question is, why is the classify the green box before the agent? It's intentional. Here is why. So you can actually ask the LLM what reasoning effort I need to set for this query, or you can write a heuristic based algorithm to decide that ahead of time. Because this is like chicken and egg scenario. It's not that bad if you call the LLM to decide before you start. But in this case, we know what queries we send. Like you have a good sense of what the queries look like, and I'll show you it's just a long list of scoring that you have to do based on the query, and you add up the scores to decide a complexity. So this is, I would say, easier to do if you know your domain well. So once you know your domain, you know what complexity looks like. So one of the ways that I did this in a different project is we took like 300 different queries, okay, like common queries, ranging from the easiest to the most complex, and had our subject matter experts label them. Now we can take the data set and study it and write a C# language, like whatever language you want, Python, whatever, just logic that says add up scores if I find this query. So you may have regular expressions there, you may have patterns that you want to match, and then you keep adding scores, and depending on the final score, you decide at what threshold minimal reasoning effort is valid and what requires high. I can show you an example of that here. So I worked with Copilot to generate this code, but if you look at the approach, I decided 0 to 10 means minimum. Right? How? Because I want my test to pass. Remember I told you about that golden data set with labeling? I want it to pass as much like 90%, 100% accuracy. So the input to this reasoning effort classifier is the query, and the output is the reasoning effort, complexity level, right? And then you map it to the spreadsheet, and you say how many of those questions actually pass. So there is a process to do this, but it's not that complicated, right? So look at this. Contains pattern, right? Has W2 income, 10 nights. So this is very domain specific. So for your domain, your reasoning effort classifier might look different. And it takes milliseconds to execute this. Why pay the tax of sending it to an LLM, right? So this goes on and on. It's not that complicated, but it's very easy to write this algorithm, especially using Copilot. So here you can see how the switched case statement on total income sources, 2 sources, 3 sources, the score goes higher and higher. Income diversity bonus, 0 to 20 points, so on and so forth. You get the idea. Any questions about this flow as to how it works? Can LLM provide X and Y coordinate if I provide a sample form and ask LLM to return? It's possible, but you want to do it at design time and iterate over it, test it, run your test suites to make sure those coordinates are accurate. What makes this need to be an agent and not a workflow? The tax scenario is completely dynamic. I cannot code for that tax scenario ahead of time. That's why it's dynamic. Right? It's not predetermined what tax scenario I might come up with, right? Well, the big beautiful bill passed this year, so now I have to come up with all kinds of new scenarios. Well, the same agent may work for me, right? All I have to do is provide it the context.
Just an observation here. A couple of times you've talked about deterministic versus something
Yes.
used in LLM. Technically, there's a point. If I could suggest an iteration, it is to fully code or discover a deterministic scenario would take a far longer investment of my time than to just let the LLM do it. In some cases, you're actually doing deterministic things,
Yes,
but you're letting the LLM do it because it's just a way more efficient
absolutely.
way.
And there are some things that you can do it at design time. You
Say more.
still use the LLM, but you use it design time and you test it, you evaluate,
Yes.
like the coordinates example, right?
Always with boundaries.
Yes. You don't want to do it runtime because it's expensive and they don't change. The coordinates are not going to change, right?
Yeah, I'm thinking more about your code generation.
Yes.
Rather than you coding it, you're just letting the LLM do it, even though you could if you invested the time. Or if you went and read the whole BBB.
First you have to write the spec, like take the example of reasoning effort classifier.
That's right.
If I didn't know, if I just told it, oh, develop a reasoning effort classifier, that may not work for me. In fact, I tried that.
Give more context.
Yeah, you need to give the spec.
Or
Like,
more granular execution.
Yeah,
So,
and tests, lots of tests.
Yeah.
And how are you finding the ROI?
Can you tell me more about what you mean?
So on this use case, right?
Mhm.
Are you checking the ROI? Are you getting the, for the
Well, we have to take this from prototype to production, which is what my goal is. And then you have to measure what was the time that was spent by manual effort, right? And you then look at this and compare it.
cost to?
Yeah. So you have to do costing, you have to do estimating the effort, that's the engineering effort spent on this. So there are lots of variables. So you have to come up with a costing model of, and in AI projects, there are templates for doing costing models. You might want to look at it. Lots of things are available on templates, available online. For
It's
RAG,
also-
it's a kind of solved problem, but not for the complex scenarios.
It's also fun
try
because
something like SpecKit, GitHub's SpecKit.
Yeah. Yeah, I've tried it. I like it, but what I found out is if you know what to do, if you have a clarity of your problem and the solution you want to build,
Yeah.
it's easier to iterate with GitHub Copilot or Claude Code to write the spec.
It is because you are a domain expert, right?
Correct. Like you have to know the context, like the background of your domain really well.
You can also use chart PRD, that's a tool available.
So there are many like shortcuts you can take, but what I've always found is if you use some of these tools, they will give you a good start, but they'll never be perfect. You'll have to do a lot of iterations before you get it right. And sometimes some of these spec kits and others have a tendency to bloat it up, like too verbose. I don't like if you want to look at some of the specs that I am comfortable with, they're very concise and they're as small as possible. I don't want to explain things that are not really required, right?
they will get you so excited about features that all of a sudden you're no longer at MVP. So if you ever find yourself in that moment where like this is magic, it's just generating code, it's all, then you are in that zone where you've done too much and things are not going to not work, and you should go back to your MVP, ask
Yes.
yourself, how do we simplify?
It has to be always how simplistic can I get this at the beginning, and you only add complexity when data tells you that you have to do it. Like there's no choice.
And then sometimes there is a complexity that the tool can't do quite right either, so you spend your time fighting with the tool.
Yes, that's always the case. But it's usually when the spec is ambiguous. Every time I've found some of these tools fail or make mistakes is when something is not clear, because you say one thing up top and way down here you say something slightly different. then LLMs may get confused with it and they do all kinds of confusing stuff. So one of the things that the skills, like these are soft skills that we as humans have to develop, is reading and comprehension. Elementary skills, unfortunately, but that's what it requires. Like you literally have to sit and read stuff. Some of us love reading documentation, most of us don't. I'm one of them, but I had to adapt. Like I had to spend a lot of time just reading, which is boring, but you play some good music and off you go. Here is one of the definitions of an agent. It's an enthusiastic engineer with broad access. So if you ship agents to production, then this is something that could happen. So what are the do's and don'ts? Give them guardrails, right? What are guardrails? These are literally, instructions that put constraints on the agent. And some constraints are driven by code, like the budgets we talked about, right? Tool call budgets. Some constraints are literally written in your system prompt. Telemetry, like you have to do traces, spans, cost estimation, metrics, all of the operational stuff. Budgeting, you have to have per task caps if you have a very complex automation that you're trying to automate. Kill switch, very important. You need to be able to abort the operation at any given point. There has to be a kill switch. And this is all applicable to advanced agents, but I wanted to make sure I shared what I learned. Don't make these agents very complex. Always start with, like I said, simple agent, handful of tools, maybe a dozen, right? Maybe 20, but not more than 20. Don't let them call tools unbounded. We talked about this. Don't ship without eval gates. Absolutely not. Or not knowing what the SLOs look like, right? You have to have a good sense of, okay, if I deploy this agent, what kind of SLOs do I want? Like maybe your first guesstimate is wrong. That's okay. You learn from production what's happening because you're measuring it, and then you continuously iterate over it. This is like the most important first principle. If you don't trust the LLM, nothing is going to happen. Like it's just impossible to work in this space. A lot of us are very skeptical about AI, and we tend to think, it's non-deterministic, maybe it won't work, I want 100% accuracy, I can't ship this. You may think like that, right? It's normal. Anthropic does a very good job of advocating for trust the LLM concept. That's why the Claude code success tells us that if you trust the LLM, you can really build, using simplistic approaches, you can really build powerful products. High quality tools, number 2, very, very important. This can make or break the product, right? If you just, don't pay too much attention to tools, then your product is likely going to fail and it may make mistakes and you'll end up blaming the LLM. It's not me, it's AI, right? Easy to blame.
So what are some of the examples of tools? High quality tools.
Yeah.
Within Turin, you're saying functions, right?
Yeah.
Software functions?
Yeah,
Azure functions?
just C# code functions or Python functions, but they have annotations on them that say, this is the name of my tool, this is what it does, this is the input, this is the output, like request response, what it does internally, what's the logic look like, all of that stuff. Yeah. Golden data sets, we talked about this. These are very critical. You need expert humans who would come up with the data set and label the data, because this is what's going to give you confidence that you can finally ship agents into production. So run evals over those golden data sets first to get that confidence. Then do sampling from prod. So this is another thing that we have been doing for more than 2 years now, is we sample from production, we redact the sensitive information, and you can use this sample data set to build up your existing golden data set. So you can run more and more as you learn from production, right? It's an iterative process, very operational, but well worth it. This is the litmus test on all of these. If humans can't tell which tools to invoke, what they do, don't expect LLMs to do it accurately.
So if you're going to cover this in coming slides, please tell me to wait. But I have to imagine in a commercial context, you're using GPT-5 Mini. Why not GPT-5 Pro? Well, because it's ridiculously expensive and slower. So latency and cost are always observability factors. At some point, you're going to want to say, what is the minimum model I can get by with cost-wise and still do a great job for this task? And these data sets obviously would be valuable for that as well, but talk about that in your experience.
In our experience, there are two approaches to this. One is to start with the least expensive model and not worry about quality, right? That's one approach, like you said. And the other approach is to use the most advanced frontier model, which is today GPT-5 Pro, and test it out, like run your evals. Well, there are some limitations. First, it has to have dedicated capacity, right? If you look at Azure AI Foundry, only GPT-5 has PDUs. GPT-5 Mini doesn't, although this is my favorite model, because it's Mini strikes a good balance between advanced reasoning capabilities and latency and cost. So to me, like, I always start with 5 Mini and then figure out, okay, what's my accuracy look like? For some, I might want to use the GPT-5, like the main model. But unfortunately, not all models or the different series models are available with dedicated capacity. And that's one of the factors, because I don't want to ship a AI product.
Well, not all of us work at H&R Block in tax season.
I know. I know many customers use just pay-as-you-go, and that's totally fine. And in fact, we have a lot of apps that use pay-as-you-go, which is perfectly fine, right? There's nothing wrong with it. But just don't expect consistency. In the morning, it looks like, oh, everything is flying, and in the evening, it might be like, okay, it's really slow, right? So if you can manage your customers' clients' expectations that way, then it's totally fine. Now, I will tell you what I believe is the right approach, is always start with the frontier model, like the highest quality model. Make it work for your use case, run the evals, and then worry about all the factors, like, is it fast, is it scalable, all the factors, right? Because what that tells you is, it tells you about the use case and the value of that use case. Because you can actually demo it to your business partners and product and say, this is the quality of the product. This is what's possible. If you start with a inferior model, let's say
everybody quits on you before you get
exactly
finish the project.
Right?
That's smart. Yeah.
So we always start with the highest model ever possible, and we only downgrade it to a previous model if the use case really demands it, and our users are like, I don't want to wait for 5 seconds. I want it in milliseconds. Well, use 4.1 and you're just fine. But you're not going to expect high quality responses, and the accuracy may be low, but maybe you're fine with it. Which is why you have to offer them, the users, with adaptive approach, where it can be a sticky approach too, where ChatGPT, for example, right? If you decide I want a thinking model to always answer my question, it's always going to answer using thinking model because you're ready to wait, right? But if you say, okay, skip it, I just want the fast answer, then you get a fast answer. So it depends on the use case, but what we have found is it's best to put the control in users' hands. Let them decide what they want. But that requires UX. Final thoughts. I know I share a lot of personal experiences here, not necessarily my companies, because many of the times what I end up doing in my job is experiment and research. and come up with imaginary scenarios, imaginary problems that I want to solve. Why? Because to check the feasibility of the technology, right? Once you understand how to solve business problem using technology especially for a AI space, it's like you can then apply it to a whole host of problems. So a lot of people start with business and then decide what technology to apply. My approach is I start with technology to really understand technology really well, so that I know, okay, out of these 12 different problems, which ones can be applied to which technology, like what model to use, what patterns to use. So understanding these patterns really well, deeply, hands-on, I think is very, very valuable. Then you don't have to really worry about any business problem. You can apply these patterns. Maybe some problems require you to apply only 5 patterns. Some of them may require 10, but you know them really well, right? So this is called intuition. I know OpenAI uses this term a lot in the last year or so, is because this intuition is really important for you to design your products in terms of technology, to get those AI systems right. And that only comes from experimenting and experience. This is another thing I learned, and I don't have time to go deep into this, but progressive AI architecture. So what this is you don't develop the ideal state at once in the beginning. You try to identify steps where humans can rate the steps, the outcomes of each step, and they can provide feedback. And this is not a new concept, but when you are building agents, not RAG solutions, then it's different. Because the first thing you have to do is how many steps exist in a given workflow. Are they all open-ended? Some of them are deterministic, right? Do you really need human in the loop for deterministic ones? You have to ask those questions and spend a lot of time thinking about the spec I talked about. So you have to iterate over it and then decide what the steps look like. In fact, we are working on really complex workflows. And that's why this progressive AI architecture. That's okay. Is very important, is because
That's your agent.
that's exactly right. When you have complex workflows, this is all I'm going to say. When you have complex workflows, think about identifying those steps in the workflow which require human in the loop, and apply agentic AI patterns only where it matters, based on everything you have heard, and then experiment with it. Already talked about mindset shift. And number 4 is what led me to sharing all this with you guys, right? Researching patterns that you can see in leading AI agents, which are the most successful AI. What does Cursor do? Does it index all your code and ship it to its cloud servers? What does it exactly do? And it's very hard to, like you have to do HTTP interceptors, for example, to learn how to do this. But if you do, you'll know that there are these patterns that come out of such products that we can learn and apply to our businesses. Here are some samples that my friend Bala from Microsoft shared about agentic evals. So he's been working on some samples. I told him I'm going to share them. But agentic evals are harder than regular evals because there are steps, there are tools. So you want to write unit tests to verify all those tools independently and together and with different permutations and combinations. That's why they are hard. Because the tool call flow is very dynamic. How do you test it? Right? Thank you. I'm on X and LinkedIn. I would love to connect with you all and learn from you if you have anything to share. Has anyone shipped AI agents in production here? You have? Awesome. Did you use Copilot Studio to build them, or you built everything from scratch?
Scratch.
Awesome. Great job.
Graph and Agentic AI.
Excellent. That's cool. Is there anything that you saw today? Did it jive with you? And is there anything that is different? I'd love to learn.
I only have one React agent in production. The other agents are all DAG agents. They're a little different. Because LangGraph agents, you sort of, they're like React in a way, but many of them like execute for 30 seconds, a few minutes, complete. So they're not the same level of feedback loop as like a React agent where you expect a response.
Yeah.
Kind of an immediate UX scenario.
These are like fire and forget scenarios.
Well, they're more like fire and check back in
Okay.
a minute or two. So you build the UX.
Grab a coffee.
You build the UX around that. And,
Okay.
But LangGraph's really interesting because you build a state graph of executions. So like in one of our workflows, we may have 3 different mini React agents happening, but it's going through like a decision tree as it solves a complex problem. They're pretty cool, and I think they're actually easier than React agents because you control the step of each tool call much more closely than you do a React agent. So I don't know.
Yeah, I think if your use case is, clear in your head, like the flow, then yeah, you don't need a React agent. Did you have any challenges, like any problems that you still haven't solved? Would you like to share?
The biggest challenges I encountered were if you're providing lots of context in some steps, not only does it make the calls slow, most models have really bad context loss when they're getting near their context count. So we spent a lot of time optimizing for removing context from context before we tried our reasoning steps, which is probably the biggest performance gain we've ever made when trying to optimize things. Because in a lot of RAG-based workflows where you're trying to provide massive amounts of knowledge to something, you have to filter out the noise even though you get a lot of high scores on the ranking returns and things like that.
Did you do token-based context pruning?
We did, but it's just not as effective as just straight up removing useless content.
If you know what that useless context looks like.
Yeah, but also
Pick and choose.
That's where you can use lesser models because like some of our tool calls are model calls, but they'll be 4.1 mini to evaluate a document for should it be included in the reasoning step. And that's much cheaper and faster than, and finally you get to your bigger, more React style call. And you've kind of tuned every document, like that one definitely belongs here when I'm trying to make.
You fed the minimum necessary context.
Yeah, we're trying to get to that minimum necessary.
Do you have any ML models sitting behind either agents or tools?
What do you mean?
Like imagine a scenario, this is something that we are experimenting with, that's why I asked. Imagine you have a very specific use case where you feel like, I need an ML model, I don't want AI, right? Because you have a classification problem or, I don't know.
And it's a very tight problem.
Very
space.
tight problem, where it doesn't leave a lot to imagination. So in that case, like named entity NERs, because you're domain specific and you may have specific NERs. And let's say you build that model and expose that API to that model through a tool call in your workflow, then you got best of both worlds, AI and ML coming together.
So like sentiment analysis?
Yeah,
Like people
well,
from in an
LLM is really good at sentiment analysis. So.
That's true.
But very specific tasks that for which you have enough data set. Let's say in your domain, healthcare or whatever, you have data that you can use to train an ML model that shows up as a tool call.
We have some stuff like that, but it's more of a statistics-based ML model, like doing a linear regression. not not like an
Not a
NLP
trained
level.
model.
Yeah. But yeah, that would be cool.
We're exploring that right now. We have a neural network model
Okay.
that we're trying to, well, we already have APIs. We're
Mhm.
exposing that model through those APIs so we can connect the Gen AI with that neural network.
Exactly. That's the pattern that I'm really interested in, because then you get best of both worlds. You can decide for which task you want an LLM, which task. And have you tested it, or you're still
We're
working?
still in the POC
Okay.
phase of that.
It's very tough to do though, because one might say whatever the ML model is doing can be offloaded also to LLM. So it's like you need a very comprehensive testing
Yeah,
strategy.
we've also struggled a little bit with initially when we were doing this, we struggled with the context window.
Yeah.
We blew through that a lot of times. I would say use temporary tables, like a lot of times we were putting things in stores, data stores,
Mhm.
to help with that, so we would exceed the context, because we were working with really large data sets, and sometimes, well, with GPT-4 we were going through at the time. It's much better now in GPT-5.
Yeah.
So you mentioned large data set. I mean, did you also consider labeling or data engineering to reduce the compute?
Yeah.
How do you handle that?
Having good, like, back to this golden data sets, and like having normalized or having the data set, like have descriptions and all that information, like labeling it is really good. Because then the LM isn't guessing. Like we
Correct.
found initially, the LM was doing a lot of introspection.
Yeah.
A ton, trying to figure things out. And so you can speed up the overall execution and everything by labeling, descriptions, like all that information, like providing that structure.
Right, so the key here is the data engineering team is key, but it's critical in this process to help your finding.
Yeah, we worked very closely with our data platform team to basically improve that. Like, and we also had to fix our ingestion processes. as part of that too.
I can provide a little more context around why we need the context engineering and why LLM struggle with context. When you feed in a whole lot of things in the context window, like, and if you look at the core of the transformer model, the attention mechanism, like the QKV, the way the attention mechanism works, it is performing dot products or cosine similarity between all of the different tokens, right? So the more tokens you have like that are similar to each other, that can take the attention and spread it across in different regions. So
Like
if you
focused attention.
when you have like more similar looking things, like the model can internally get confused on what it needs to focus on. So that is why like context engineering might still is still going to be around even if the language models support much more larger context.
And context engineering is probably more important than prompt engineering, because from the last year, like I said, we're all about prompts, right? Prompt sharing has become like a Pokemon cards or whatever, right? Everybody was like, how did you do this? Send me that prompt. Well, not so much right now. Like, and we were so used to being very polite to LLMs, like, please, thank you. No longer. I don't use it. Like, just this is what I wanted to get done and do it, right? So with context engineering, though, you remember that JFK meme. So that's what's important. Like, if you can figure out what you want to provide. For example, in your case, you said, okay, context window is filling up. We can do, pruning of that based on how much tokens are fit into the context window. But is that really the right way to go about it? Maybe not, because maybe there is more context that needs to be optimally configured and pruned. So something called smart pruning. So you literally have a separate process that looks at everything that's stuffed into your, it's like taking stock of the inventory, right? And you smartly decide, where am I at in the step? And based on this step, I want to purge this information, that information, that information. So it still has context required. But doing smart pruning is not simple, and you only do it when you ran out of all the other ideas. Have you tried that?
Well, we solve that by using a DAG instead of a React. So
Okay.
instead, you just do them in separate steps. So
Okay.
you get to split your tasks and not do it all in one.
The challenge we found with splitting everything, we shipped a multi-agent system, okay, in test mode. And what we found is the more you split up and create these army of agents, the harder it becomes to orchestrate between them. And you cannot even imagine, like, especially in dynamic scenarios, you think this agent should handle it. But there is always an edge case where that agent is not given the control to execute the task, and some other agent comes in. And that agent has no idea what happened. So contextual awareness is something that is very key to building out a smooth workflow, so that there are no steps where there are no failure modes in those steps. So lots of lessons learned from that multi-agent experiment. That's why we now always gravitate towards one agent, bunch of tools, and let it fail. Let the data tell you why that is not working. And the next step is what is called as sub-agents, not multi-agents, but sub-agents, and there is a difference. And in even those sub-agents, you have manifests for those agents. So you define what skills you have to offer to each of those sub-agents. And Claude does this really, really well. It knows you want a code review agent, or you want a test creator agent, or you can define them, and it hands off those tasks to those sub-agents. But you only want to do that when you really need to. Don't start with a complex, I explained it in Dobu.
I think multi-agent, it works when you start with the back end, making sure each of the agent works. Just keep evolving them, right?
Yeah, but again, your use case may,
Depending on the use case.
yeah, in your case, you may be like, yeah, multi-agent works for me. But if you have a process that you're following, you want a non-deterministic process. There is a beginning, there is a middle, and there is an end. You know what those 3 points are, right? But you don't know what could happen in the middle. For example, if you are onboarding a client in our tax software world, and you cannot really, like, if you walk into an office and sit next to a tax flow, it's very hard to imagine what are all the conversations that may take place. It's very dynamic in nature. It depends on each client's requirements and what that tax flow is capable of doing, right? But you know there is a beginning, there is a middle, and there is an end. And the end is, okay, I filed my return. Success, right? And there is a beginning, I need to collect all your information. But when you don't have a clarity on what could happen in the middle, you need all those capabilities to be built up. But you cannot orchestrate them with a predefined path. But if you have a predefined path, maybe it's fine. I don't know.
I always thought that the best thing to start with is a way to reduce the amount of time you spend on dull, mundane, repetitive tasks, like looking for duplicates in your database, that type of stuff. It's very specific, and the thing can go ahead and read it and give you back a list, and you can determine from the list whether or not, oh yeah, these are duplicates, or no, this is really something different, and then you can explain it back to the thing.
Yeah.
And start with that.
Sure.
As opposed to dealing with humans and using an AI to deal with humans. It's hard enough for humans to deal with humans.
Well said.
Along with the hype, I don't think we're in any danger of having no jobs. I don't think these agents are going to take over human jobs just quite yet.
Not this year. I don't know about next.
Like, now there's whole jobs to do agent testing. Yeah.
You still need a domain expert. You still need people who design these systems. There are problems to solve, and there's always new problems, because none of these problems needed to get solved, like context pruning. Like who thought about we need to do context pruning, right? Somebody has to think about it. So yeah.
And I think you can do more.
Yeah, you can take the same time that we have today and solve more business problems and scale and find new problems to solve.
So what's amazing is to get all this architect role, EDA role, everything together.
Sorry, running out of questions. Last chance. Last chance for questions. Great mind.
Yep.
Who learned? Oh, you got one more question? You got a question? Go ahead. Last chance.
Yeah. So I feel like writing the tests to validate everything is really a lot of work, or at least very tedious. Have you done like that example where you did that form, like single filer, junior, engineer or something? When you validate it, was it just a bunch of rules, or was it an AI that validates it?
Sure. So the question is, how do we, like, it takes a lot of time to test, right?
Yeah.
How do we validate it? So it's like a cycle of repetitive testing that you have to do. For example, in this case, it took me like 7 or 8 iterations to make sure that the coordinates are right, it's printing in the right location. So that's I mean, what's the alternative? The alternative is, for every possible scenario, doing it again and again, repetitive tasks, right?
Can you get an AI to do that?
So,
Can you get an AI to do the validation?
absolutely. You start with AI to accelerate your process, but you don't assume that what AI gave you is the final one. Because sitting down and doing all this work from scratch takes a lot of time
Like
and
for
effort.
example, the salary, right? You said it's invalid. It's easy to validate that if it gives like a 10-digit number that's unrealistic. But if it was for that specific role, which is entry level engineer or something, then you put in like CEO, it would be a different validation.
Yes.
So can you use the AI to classify that role?
Absolutely.
And then figure out the reasonable range for that.
Absolutely, and that's why you start with AI and you generate those tests using AI, and then validate and verify using your human experts of the results of what was produced.
But in production, it's still just a bunch of rules. It's not AI that's validating it. Right?
Like you're talking about how do we validate in production?
Yeah. Because you had a part where you showed it, like it was actually in telemetry part, it was actually doing the validations.
Yes.
That's a rule. That's rules. It's not AI, right?
Yes, but what you really have to do is, I talked about sampling from production. So in the MVP phase, you have to do a lot of that. So maybe you sample a large percentage of data set from production and write automation on top of that to validate it. And then you can also look at fine-tuning an LLM using that data set to make sure you can automate the eval process too. That's really the next step.
All right. Who learned something tonight? Yeah. Everyone's hands up. Yeah, me too. Worth everyone's time. Let's hear it for Vin.
Great.
Thank you. Some of the best presentations I think have been. Vin is a member of the community, right? He's one of us. He lives here in town, chosen to share his knowledge, and I think some of you'd agree. Those are some of the very best presentations we've had. So that was definitely excellent. Can't wait for your third time, Vin. Maybe not to leave it. Let's not leave it 18 months this time. I can't believe it was that long.
I don't even remember it was 18 months.
Yeah, me neither. It didn't seem that long ago. So yeah, we'll have it sooner than that, a third time, and then it'll all be different. So thank you all too for coming out and participating. I mean, it was great, all the chit chat we learned from one another. Really appreciate it. There's still a bit of pizza left. Please take some home. Thanks everyone online for coming out. Next month we're taking a break. We can't. December's a light month typically. We usually have them in December, but so few people turn up that we thought we'd end on a high note this year. What do you think? Sound good? And we'll start again in January. So hope to we'll see you next year. Thanks all.
Thank you.